Power is a major expense for many plastics facilities, and it's a key contributor to the cost structure of the end products produced. So many of us focus on how to reduce the power we use, but poor power quality has become one of the most serious issues in industrial facilities. Some of the results of poor power quality, such as component and equipment failures, missed deadlines, and lost revenues, are listed on this illustration. The Electric Power Research Institute estimates that poor power quality costs American industry up to $188 billion a year in direct costs as well as lost productivity. For plastics, that equates to about $9.6 billion annually. There isn't another cost reduction potential in industrial plants that comes close to this staggering total. But what's more alarming, industry studies have shown about 80% of this number is caused not by power quality from your electric utility, but by self-induced problems inside your facility. That's actually good news for many processors. Since the vast majority of these problems are diagnosable and preventable, they represent an opportunity to realize significant cost reduction. The bad news is poor power quality is frequently misunderstood, and as a result, it's often ignored. Let's talk about some of the special symptoms of poor power quality. Poor power quality symptoms may be all around you, but they can be hard to recognize. They often seem to occur randomly and always at the worst times. As we mentioned, you suffer through unplanned downtime caused by motors that mysteriously die, often from winding failures, machine controllers that suddenly reset or lose their values, damaged drives, capacitors that short out, and more. Because production is critical, those failed components are often replaced instead of diagnosing and fixing the root cause, until it happens again and again and again. This endless cycle causes part replacement costs to soar, and of course, the lost production time may never be recovered. These repeated or premature electrical component failures are incorrectly perceived as being the result of poor part quality, or sometimes blamed on faulty machine design. In reality, they are often symptoms of poor power quality that can be corrected. Aside from the obvious impacts of component and machinery failures, more subtle clues about power quality in commercial operations may be easily overlooked. Items such as machine speed, part quality, and process throughput variations may well be indicators of poor power quality. The resulting impact that these factors have on efficiency, effectiveness, and profitability are a major reason why power quality evaluation and monitoring are a growing requirement in most industrial environments. Power quality is actually a growing problem all of us face. In industrial environments, machines are often equipped with variable frequency drives, or VFDs, servo drives, and solid-state relays to optimize energy usage and process efficiency, speed, and precision. While these devices have helped processors do more with less, they do bring along a surprising and unintended consequence: the increased potential for power quality issues. In the case of drives, they use DC power to create the artificial frequencies and waveforms for precision motor control. But without isolation transformers, you may notice small motors nearby are failing more frequently, or PLCs are losing data or rebooting unexpectedly. These symptoms result from harmonic distortion generated by these devices that disrupts the surrounding power. It causes excess heat buildup in motors and also causes mismatched voltage and current waveforms, or dirty power, that can cause digital I/O to malfunction. The proliferation of electronic devices is also contributing to poor power quality in administrative environments. DC power supplies and chargers are all around us in devices we depend daily on, like laptops, smartphones, and telecom equipment. They are in advanced machine controls, copiers, printers, and even energy-efficient LED lighting. And as a result, they generate harmful harmonic distortion, just like industrial drives. The irony in this is that the same devices that are benefiting from those technological advances are also the victims of it. In the office or in the factory, you may see increased memory faults and reboots, communication errors, and other device lockups. You may also experience power supplies, laptops, and small machine or HVAC exhaust fans failing sooner than expected. In many cases, devices being powered are not causing a power quality issue. but they are part of an improperly planned electrical expansion, and in that circumstance, they can still lead to poor power quality. Most plants evolve and expand over time. If the single-phase devices are all wired to phases 1 and 2 of a three-phase distribution bus, there will be more power drawn across those lines. That unbalanced loading results in a significant voltage imbalance with a three-phase motor on the same supply bus. It becomes the unintended victim and could fail prematurely. This voltage imbalance forces the motor windings to carry more current on the lower voltage lines, which creates excess heat. In fact, a voltage imbalance of only 5% causes a 50% increase in the expected temperature rise of electrical components. This causes devices on those circuits to run hotter and reduces the life of the windings in motors, transformers, and heater elements. When these circuit voltages drop low enough, the voltage imbalance can also cause VFDs and other electronic devices to reset or overload. The result is downtime and sometimes significant part replacement cost.